Hello, today we're looking at 1.2 domain and range, and for this part we're going to look at domain and range of functions. This is going to be broken into 4 videos, so for this first part let's go over learning objectives or learning outcomes. Find the domain and range, domain of the function defined by an equation, find the domain of a function from its graph, and graph piecewise defined functions. So the domain is a set of independent values. Typically that's x for us in our setting. It could be a t, like if it's f of t or f of x, or whatever the value is, the independent variable is going to be the domain. The range is a set of dependent values, usually y in our settings. So we're going to look at this here. So let's move on here to talk about this. Find the domain of the function defined by the ordered pairs. We have -5, 4, 0, 0, 5, -4, 10, -8, and 15, -12. So the domain here would be the set -5 from here, 0, that's 5 there, 10, and 15. So finding the domain given a function written in the equation form. Identify the input values, identify any restrictions on the input, and exclude those values from the domain. Write the domain in interval form if possible. And so let's go to example 2. So what I had skipped up here, this is our interval form. So like if you're talking about a to infinity, we do a comma infinity. And so notice this a has a parenthesis here, means it doesn't include the a value. Or like this one here, it doesn't have a lower one. This one didn't have an upper one. So it goes on forever up. This one doesn't have a lower one, goes on forever down. So -infinity to a. Now this one has a bracket instead of a parenthesis, so it includes the a value, so a to infinity. It doesn't have an upper limit though, so it goes on forever, a to infinity. So now here we have -infinity to a. So it's inclusive of the a because it has the bracket. Notice over here x is less than or equal to a. Here's ab, and so it's all the values in between a, b, not inclusive, so it says x is strictly between a and b. Here's a to b, inclusive of the a but not the b, so x is between a and b to include a. Then we have a to b with the parenthesis on the a and a bracket on the b. So x is between a and b to include b. And then we have brackets on each end. So ab, that means we include both the a and the b. So x is between a and b to include a and b. Or it might just say inclusive. X is between a and b inclusive. Okay, so down to here for example 2, when we find the domain of the function f of x equals 5 minus x minus x cubed. In this is a polynomial, and there's nothing that we have to worry about. It's not like we have a fraction or a radical. So our domain would be -infinity to infinity. Everything works on that. There's nothing to exclude. Okay, find the domain of a function written in equation form that includes a fraction, which is what we're going to do next. Identify the input values, identify any restrictions on the input, so like what makes the denominator 0. So if there's a denominator in the function's formula, set the denominator equal to 0 and solve for x. If the function's formula contains an even root, set the radicand greater than or equal to 0 and solve, so like the square root, fourth root, or whatever, you can't do that for a negative, so you take the part under the radical, then you want to be greater than or equal to 0, because it can be 0 for a radical unless it's in the denominator. Write the domain in interval form, making sure to exclude any restricted values from the domain. So here we have f of x is 1 plus 4x over 2x minus 1. So unless something were to reduce, even if it did, we still have to worry about anything in the denominator, and we call that typically a whole. So we're going to take this 2x minus 1, set it equal to 0. So 2x equals 1, or x equals 1/2. So that's what we had to exclude because we cannot have a 0 down below in the denominator. So our domain is going to be -infinity up to the 1/2 with a parenthesis, because it's not inclusive, union that with 1/2 to infinity. So this is showing all the values, basically negative infinity to infinity, but it skips the 1/2. Finding the domain of a function written in equation form that includes a root. So identify the input values. Since there is an even root, exclude any real numbers that result in a negative number in the radicand. Set the radicand greater than or equal to 0 and solve for just 1x. The solutions are the domain of the function. If possible, write the answer in interval form. So we have 5 plus 2x needs to be greater than or equal to 0. So this is a square root. So it would be a 2 there by default. If it was a 2, 4, 6, 8, whatever, we have to do with this. If it was an even or odd index, it doesn't matter. I mean, in that case, you can have a negative. Okay, so I like to keep my variable on the left side intentionally when I'm doing inequalities. It just helps me personally to interpret what's going on. So it's subtracting 5 from both sides. 2x is greater than or equal to -5. Dividing by 2, x is greater than or equal to -5/2. So it would be bracket -5/2, comma, infinity with the parenthesis. I should note, you always do a parenthesis with the infinity because you're never at infinity. Okay. So I think we're going to stop there because the next part we're going to talk about set builder notation. So that should make long enough for this video. See you in the next one.